So what is the merge sort? Is one of that most demanding algorithm, right, for a merge sort here. And you need to understand that how merge sort works here, correct? And it is much more similar concept, what we can call as to binary search, right? The way we do things into a binary search, same way we do these things into a merge sort as well. So in binary search, if you know that we divide by 2, then we take up that middle element, then we basically compare and do the sort and something like that, right? In the same way, the same concept we use it here into what we can say in this sorted here, right? So in generally in binary search, every time we divide by 2 and compare with the middle element and we try to search, right? Here we take one more step. We every time we divide by 2, right, till that time we have a single element and we basically merge it. That is the additional step we need to call it. So we divide. So here we concept is comparison based sorting algorithm that divides an array that into smaller sub arrays here and sort these sub arrays, करेक्ट? तो जो भी एरे वी डिवाइड इट, राइट, जो हम डिवाइड करेंगे, राइट, एवरी टाइम वी टेक अप लेट्स से 5 element array, we pick up that mid element, divide, again we divide and we merge it, then merge them back together to produce a sorted array here. This is a basically you need to understand, right? So this is basically much more related concept here. And every time we divide, so that's why definitely the time complexity will be calculated based on that logi formula, correct? So that is basically you need to understand it, correct? So how to merge that sorted array here? So first we divide the array recursively, right? So we use that recursive function every time we, the way we do things into a binary search. So every time we call that recursively same function and pass that from that mid element to a starting element, and we divide again, and then we try and compare. In the same way we also do it and divide it here, right? The array is recursively divided into a two small holes until the each subarray contains a single element and it's empty here, or it's an empty, right? And single element array are inherently sorted, because if you will get a one particular element, it is already sorted, you don't need to do it, correct? Then once you get that, till that time is single element, then we will basically start doing the merge here, conquer. So the sorted subarray are merged together to form a single sorted array. So the merge process involves combining two sorted array into a one sorted array here, right? So that is the basically that merge is, you need to understand it. Divide concept, you will get it very straightforward. There will not be any such major challenge when we are talking about divide here, right? So that's why I told you, I have explained it also. So splitting the array here, divide the unsorted array into two halves, right? And every time we need to divide until you will get a one particular element or it is an empty one, correct? Merging process, merge the divided subarray into a way that combining the result into a sorted array, right? So use two pointers to compare the element from the two subarrays and build the merge array here, correct? So this is the one of the key point when you are writing that merge, you can say steps, right, like this. So this is basically you need to write it. The concept will be remain same. You need to pick up that pen and paper and start writing that each and every steps first into pen and paper, right? So this will be the steps, this will be the input, these are the some additional variables if you required or not required. And then if you are writing a loop, you can write some loop, and then how you will process and how you will do it, or this will be the recursive function, something like that you can write it out, correct? And once you write it into a pen and paper, then you can move into a what we can call as into your editor and start writing the code it here. Let's try and understand into a using this particularly what we can call as this diagram. So you will have a 38, 27, 43 and 10. So you divide by 2. So the array is basically 0. The array index from start from any language generally is for either Python or Java. You can start from 0. So 0, 1, 2 and 3. The length of the array is 4. That highest, this index will be a 3 and it will be a 0 here. So you divide by 2 again. What is happening here? So there will be a 38. So when you divide by 0 plus 3, divide by you can say 2. So the highest is basically what we will, you will have it, right? So these 38 and 27, 0 and 1 will be coming here into a one particular part here, first hall, and this is the second, always for what we can say 2 and 3. Again, you divide 38 and 27, right? So like this, till that time you divide it, right? Now you got that single element here, right? So after that, your divide particularly a concept or that loop will not going further. After that, you will do the merge here. So you will again compare 38 and 27, 27 and 38. Here you will compare 43 and 10 like this. Now, there is a critical part when you compare and merge for these two arrays. At this moment, you need to use a two particularly pointers and you need to compare and start what we can say placing the elements here. Correct. So maybe you can take it up from that 27 and compare it. If it is greater than from 10, so if it's greater than 10, you don't need to do. If it is less than or greater than 43, you can put it inside the before the 43. Pick up that 38, then compare with the 10. It is greater, pass it. Then compare 27. Okay, is greater, pass it. If it is less than the 43, shift 43 one more place and put 38. That kind of a way you can merge it. Or if you wanted to merge from here, 10 compared to 27, yes, it is lesser than. So in that scenario, you can insert it. So something like that, you can try merging concept. You can look for a kind of a concept like a insertion sort, right? The way we do into a insertion sort here, we insert and further these elements we shift from one place like this, correct? Something like that. So in one of the way you can compare and you can add it here, right? So this way you can just do it, is a much more simpler one, you can understand it here, correct? So till the time you will divide, whenever you will have, there will not be any, this particular size of the array should not be greater than 1, or it should, the size will be a 0 like this, correct? Either it is a there will not be any element or maybe only one element. The size should not be more than one of that. Till that time you will split it here, correct? And then once you got the split, you start doing the merge here, correct? So this is the overall concept of your merge sort, right? If you will look for an algorithm here, so what you will do, create an merge sort. Here you will pass the array, right? So if this array size is less than 1, then you can return, because there is a no need to sort it. If it is not, then you can go further here. You can divide by 2. So 0 to mid, you will take the left half, and so if you will go with that right side, mid to a end like this, right? And again, you will call that this recursively, right? Till that time, you will get that one particular element here, right? And then you will call to a merge, and merge, you will call that left and that sorted right here. So if you will go here, so initial level, if you will just go, this will be the left, this will be the right, and you will merge it here. This will be the right, this will be the left, you will merge it here. Then you will merge this particular first sorted and second sorted here, and then later you will do it, right? So first time you will merge this one, then you will merge this one in one iteration. Then later iteration, you will again merge this one and this one like this, correct? So this way you can, how many times you merge it? 1, 2, and 3, correct? So this way you will basically merge it. So that's why we, in the merge, we are saying is sorted left and sorted right, right? So once you will do it again, you will just do it, and you will, this process will keep on doing and keep on working it here, correct? So this is the one of the, what we can say, the algorithm is basically for divide and conquer, right? Divide and merge also you can say. And if you will see again, you will try to understand it here. Split this particularly, let's say we have this 38, 27, 43, 3, 9 and 82, right? Divide it 38, 27, 43 and 3, and the second half will be a 9, 83 and 10 here, correct? So the 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 2, 3, 4, 5, and 6. So if you will divide, it will be a, basically the index will be a 3, correct? So 0, 1, 2, 3, you will get it into first hall. Here you will get it into, again you will divide. So here you will get 38 and 27, 43 and 3. Here you will get like this, and continue, you will do the splitting here. Then you will merge, right? 27 and 38. again you will merge into a 43 and 3 like this, and you will merge into a this 38 and 27, 27, 38 and 3 and 43, and the way we have seen it into our this diagram, correct, like this. So you can check and insert it again, check it and insert it, this way you can do it. Or that how you wanted to write the merge, you can also write it here, correct. So the base case is O n log n, right? Average case is also n log n, and worst case is also n log n it here, right? O n due to additional space required for temporary array during the merge process here. That's why we are just look for O n here, correct. So this is basically you can look for a result, right. So that's why we are talking about for a space complexity, right. And every time you divide, that is the n log n, but every time you merge it, the merge will be basically you need to multiply, correct. So that's why you are taking about that merge with divide. That's why this complexity you are getting is n log n, correct. So this is you need to, what are the advantages? So stability is merge sort is a stable sort, meaning is a uh, preserve and relatively order of equal elements here, right? Predictable time complexity. It has a guaranteed O n log n, right? Complexity here, correct? So one of the disadvantage, it is required that space O n, right? Additional space proportion to the size of the input array. That is drawback of the memory constraint environment here, right. This is one of that, because in bubble sort if you will see o1 only, correct, but the time complexity if you will see og n square, right. So that is basically you need to understand how this particularly things will work. So it is very much useful for sorting a linked list. It can be implemented effectively for the linked data structure without additional space, right? And large data set that don't fit it into memory and require external sorting algorithms, correct? So this is basically you can understand it here. Now let's go into a particularly a code as well. So we will go and discuss into a what we can call as uh, Eclipse. So we will check that how it will be the code we write it into an Eclipse as well. Yeah. So I guess you guys are already aware about or you are able to see my screen here, right? So I will close that, right? This code also you guys can take it from what we can say on the chat GPT. You can take it from Gigs for Gigs, and you can take it from multiple other places, right? I have explained the concept here. Code you can get any particular place and you can validate your code and compare the code. Okay? Are you getting my point? So every time what you can say, first you need to understand it here, right? What we are doing it here, correct? So every time we divide by 2 and we divide by, this is basically the process we every time we divide by 2, this low, right, and this high here. So what is the low and high here, correct? If you will see length minus 1, so the highest element, right, and 0 is nothing but your what we can say is for first element here, or this is the array here. So what we will say, every time we'll divide, this is the highest element, the size of the particularly array is let's say 6, so it will be the fifth, right? This is the index of 0, it is will be the fifth, and the process will keep on doing and we keep on doing divide it, and later we start from the merge, correct? So the merge concept is you will see again, right? So you need to understand what is the medium here, what is the low, and what is the highest. So because every time you divide it, correct, so once you merge it, then low will be a zeroth element, but you also need to understand what is the you can say highest element here, correct. So in that scenario you need to merge that based on the particular concept here, Okay, so this is overall concept for merge here, but if you are talking about the division is majorly, you need to understand it, right? So first time we will take it from low to medium and medium plus 1 to highest, right? So let's say from 0 to 3, and then or maybe you can say 0 to 2, and then you can say 3 to 5, right? So 3 to 5 you will take it in into a next time here, like this you will have a two halves. So this way you can try and you can start merging it. Correct. So if you will take it, I will just execute this particularly a program here. Let me just tell you. Correct. Java application. Right. So this is the particularly way you can do the sorting it here, right? And overall algorithm works like that. You can take that different scenarios. Here is also you can take this particular scenario. You can also take that base case. You can also take that worst case scenario also, and check how much time you are getting it and how you can calculate that time and space complexity also. Okay, so this way you can understand that overall concept of your merge sort here, right? And you can basically try to implement it here. If you are facing any challenges, definitely you can reach out to me, right? I can also give it that code. You can write merging concept based on your own understanding here and there. You can try and you can write it, right? But it's up to you how you wanted to process it. Correct. So this is all about that particularly a merge sort here.